Hello everyone. Our project is Airbnb New User Bookings Prediction. Airbnb is a trusted community marketplace for people to book accommodations around the world. For this project, we will build a system to make a prediction about the destination country of every new user's first booking.
We design our system as the following flowchart. The first step is data exploration. We have analyzed 4 features: destination, gender, age, and date, and try to excavate whether these features have peculiar behavior and whether there are any connections between them, and how they influence the output. The next step is data preprocess. We preprocess the data with removing unnecessary data and fill in the null data with the variation and standard deviation of the available data. The final step is machine learning. We use 4 algorithms: random forest, k-neighbors, Gaussian naive Bayes, and XGBoost to train and predict. Besides, we also adjust some of their crucial parameters to improve the accuracy and optimize our prediction. The first step is data exploration. For destinations, we filter users with destination undefined and use countplot function to illustrate the destination against population. We can observe that from 2010 to 2014 as the data collected, United States is the most popular destination, and that may be due to that time. Airbnb was not so worldwide popular as now, and most users were maybe Americans, and their first choices may be traveling domestically. For gender, we count the population of female, male, unknown, and find that there are also some other genders. Besides, we calculate the relation between gender and destination and find that gender does not influence the user's decisions magnificently. For age, we plot the distribution of age and find that age between 20 and 40 occupy a large part of the population, and the peak is about 30. Inspired by the graph, we are interested in the differences between different ages, so we choose 40 as our boundary and divide the population into 2 groups and plot them as percentage towards different destinations. We observe that youngers tend to travel in United States, while elders are inclined to other countries. For date first booking, we choose the data of 2013 as our object. The figure shows the everyday booking numbers in 2013, and here is a slow growth from January to September and a decline for the rest of the year. We also translate the date to weekdays to observe differences. The number 0 to 6 represent Monday to Sunday, and we found that people are less willing to book at weekends.
The second step is data preprocessing. We mainly did 3 things in this part: fill up non-data, dropping unnecessary data, and mapping non-numerical values to numerical values. Observing the user's information in the dataset, we found that there are many non-values in some fields, so we used random values in the corresponding range to fill up these non-values. In the user information table, there are 16 attributes, and not every attribute is meaningful in the user's first booking prediction. For example, ID of the account, date of creating account, timestamp of the first activation will do no help in the prediction of user's first booking. Therefore, we choose to drop some useless columns. By this way, we can avoid the interference of unrelated information. Most of the values in the table are in the string type, which is non-numerical. This is not suitable for the next step to train this non-numerical data, so we have to map these values to numerical values to prepare for the next step of training and the machine learning model. Step 3 is prediction of first bookings. To predict new users' first bookings, we choose to use 4 different algorithms to set up the machine learning model: random forest, k-neighbors, XGBoost, and Gaussian naive Bayes. We compute the accuracy of the prediction by computing the percentage of correctly predicted users in all the users of the testing set. The charts shown in the slide is our prediction with default parameters. For random forest, we set the model and do the parameter adjustment to get better results. We mainly adjusted numbers of estimators to explore its influence on the performance of the model. We tested with the number of estimators set from 1 to 201 with step 10 and recorded the accuracy of the model for each training model. Then plot this figure to observe the changes. We can see from the figure that when the number of estimators is less than 40, the accuracy improves as the number of estimators increases. At the beginning, the accuracy increases in the highest speed, but then slows down as the number of estimators increases. After then, the accuracy increases in a very slight speed and can hardly be observed. Therefore, we choose 40 as the number of estimators in random forest algorithm to get the best performance. For k-neighbors, we set the model and do the parameter adjustment to get better results. We mainly adjusted numbers of neighbors to explore its influence on the performance of the model. We tested with the number of neighbors set from 1 to 20 with step 1 and recorded the accuracy of the model for each training model. Then plot the figure on the right side for observing the changes. We can see from the figure that the accuracy increases when the numbers of neighbors increases from 1 to 4, and after 4, the accuracy constantly decreases as the number of neighbors increases. When the number of neighbors is set to 4 or 6, it can achieve the best performance. Therefore, we choose 4 as the number of neighbors. For Gaussian naive Bayes, there is not much parameter for adjustment, so we use the default parameter to train the model. For XGBoost, the process of parameter adjustment is just much more complicated. We first tried the default parameters in XGBoost package and get the accuracy of about 0.592187. Then we adjusted some adjustable parameters to test its performance and then get the accuracy of about 0.594834. The accuracy increased by about 0.003. And then we introduced the cross-validation set in XGBoost. We split the training data into 2 parts and randomly extract 33% of the data as cross-validation set. We also adjust the parameters on the basis of a last trail. This time, we get the accuracy of about 0.606959. The accuracy increases by about 0.0212. Our project gets the prediction for new users' first booking using 4 algorithms. From the result, we can find that random forest performs best while Gaussian naive Bayes performs worst. From the process of parameter adjustment, we found that gradient boosting requires much more care in setting up than other algorithms, and we spent most of the time adjusting the parameters for XGBoost. It is perfectly possible to just blindly apply random forest and get decent performance, with very little chance to overfit. But for XGBoost, it needs more adjustment on its parameters. Also, it is much meaningless to train XGBoost without cross-validation, so it is important to choose appropriate cross-validation set for training. For XGBoost, we need to fine-tune the maximum depth of the trees and the shrinking factors. We know it is general that XGBoost performs better than random forest, but in our project, even spending a lot of time adjusting the parameters of XGBoost, Random forest still performs better than it. We are going to find the rhythm of the problem and find if the performance of XGBoost can be further improved, since the accuracy of our prediction is still not very satisfying. Also, in the dataset we used, it has another table recorded the log sessions of some of the users in the training set and the testing set. If we add this data into the training data, it may help us get more information and may significantly improve the accuracy. Thank you.